Okay, 10.2 is working with geometric series. It says, what is a geometric sequence? A geometric sequence is one in which the same number is multiplied to each term to get the next term in the sequence. The number you multiply by is called the common ratio. Does that sound familiar? Usually denoted by R. Okay, again, this is another topic that was first introduced in Algebra 1. And I know it's been a while since Algebra 1. But hopefully some things are going to sound familiar. So looking at the definition for the nth term of a geometric sequence, it says the nth term of a geometric sequence with first term a sub 1 and common ratio r is given by the following. So notice it's going to give us 3 definitions. You use the definition that matches the scenario better. For the first example, and again, this is just review, we're going to be able to use every single definition, so they're just going to show you where a sub n comes from. So the first definition is a sub 0 times r to the n power. The next one is a sub 1 times r to the n minus 1. And the last one is a sub 2 times r to the power of n minus 2. Okay, again, the reason they give you all these definitions is because, let's say instead of a sequence, they tell you, okay, we know a sub 2. A sub 2 is this value. We know that the common ratio is this value. Find a sub n. So that's the reason why there's all these different types of formulas. So since a geometric sequence is one where we're multiplying each number by the same term, looking at this first example here, we have 3, 6, 12, 24, 48. What is each term being multiplied by? 2. So times 2, times 2. All of these are consistently multiplying by 2. Okay, which means I could find the next nth term by multiplying by 2. Okay, now looking at this very first value here, would this represent a sub 1 or a sub 0? Say it again. A sub 1. Remember, a sub n identifies the terms. In the last notes, we just counted 1, 2, 3, 4 to find a sub 4. Okay, so this only gives us a sub 1. So if we had to multiply by each number by 2 to get each of the following ones, how do you think we're going to find a sub 0, which is technically working backwards? Divide by 2. So a sub 0 is equal to a sub 1 divided by 2. We do the opposite of our common ratio, which means this is 3 divided by 2, which is 3 halves. So a sub 0 is 3 halves. So following the formula, we have 3 halves times our common ratio 2 to the power of n. That would be our first formula. For the next one, what is a sub 1? 3. So we have 3 times our common ratio 2 to the power of n minus 1. What is a sub 2? 6. So we have 6 times our common ratio 2 to the power of n minus 2. Should bring back Algebra 1 fond memories. Okay, so looking at the next example, remember, geometric sequence is only multiplying. So looking at number 2 where it says 25, 5, 1, 1/5, etc. What is each term being multiplied by? 1/5. Okay, so times 1/5, times 1/5, etc. for every single part. Okay, which means 25 is representing what? A sub 1. And we said that a sub 0 is when we take a sub 1 and divide by our common ratio r So that means this time we're going to divide by 1/5. So this is equal to 25 divided by 1/5, which is the same as saying what? Okay, 5 times 25, right? We just multiply by the reciprocal, and so we get 125. That is our A sub 0. We went backwards, which means our first formula is 125 times 1/5 to the power of n. Then we have 25 times 1/5 to the power of n minus 1. And what would the last formula look like? Good. 5 times 1/5 to the power of n minus 2. So really what we're doing with each of these formulas is we're forming this summation as n is equal to 0 and it approaches infinity. We have a times r, our common ratio, to the power of n. That thing is repeating every single time. So if we did the summation of this, we would get a times r to the 0 power plus a times r to the 1 power plus a times r squared all the way to a times r to the nth power. Okay, so up to here was review. Okay, so geometric sequence is algebra 1. Now moving into calculus, we're going to talk about geometric infant series converges, so when it converges or diverges. So it says a geometric series with ratio r diverges when the absolute value of r is greater than or equal to 1. And if the absolute value of r is less than 1, then the series converges to the following. So that summation of a times r to the n power is equal to a times r to the k power divided by 1 minus r. Memorize that formula, where a times r to the k power represents the first term of the series. Okay. Notice, I know it represents the first term because look at the bottom of the summation. It says n equals k. We have to pay attention to this value because it's going to help us find our exponent. So since this was n equals k, that's why our exponent is k. Okay, so looking at example 1, we have the summation as n equals 0 to infinity of 3 over 4 to the nth power. Well, the first step in order to write this in terms of a times r to the n power, we have to rewrite this. So this is the same as saying 3 times 1/4 to the n power. So instead of just dividing by 4, I can multiply by 1/4. That is the same thing. So now in order to find my a times r to the k power, okay, I am going to look at this here. Okay, I know a is that beginning number 3, r is the 1/4, and k is going to be what? 0. So really this is 3 times 1, which is 3, because what's anything to the 0 power? 1. Anything to the 0 power is 1. So that is our a times r to the k power is 3, our initial value. R, our common ratio, is 1/4. And so we do the absolute value of 1/4, which is 1/4, is less than 1. And since it's less than 1, we know that this is going to what? Converge or diverge? Based on the definition. Converge. So this implies that it converges. And because it converges, we continue with the formula above. We're going to use a times r to the k power divided by 1 minus r. So we said that a times r to the k power is 3. We already solved for that. So 3 divided by 1 minus r, which is 1/4, is 3 divided by 3/4, which is 4. Good, that's our answer. So this means that since our common ratio of 1/4 was less than 1 after we took the absolute value, that this entire series is going to converge to 4. Okay, let's look at number 2. Number 2 says the summation as n equals 2 to infinity of 3 to the power of n plus 1 over 4n. Well, we can rewrite the numerator as 3 to the n power times what? 3 to the first power. So this is going back to properties of exponents. If they have the same base, then we can add the exponent, so which means we can do the opposite to undo. Okay, over 4 to the n power. Okay, then we can take this and rewrite this as 3n over 4n, which means those n's would cancel, and we're just left with that 3 on the outside. Okay, and that's because of the 3 to the first power times our r value, which is going to be 3/4 to the power of n. So we always have to rewrite this in terms of a times r to the k power, always. Okay, so if it's never in terms of a common ratio exponent, you need to work with your properties of exponents to rewrite it. From here, we're going to find a times r to the k power, but because of our summation, what is k? 2. So this is going to be 2 plugging in for n. So this is 3 to the power of 2 plus 1. Okay, and we're looking right here. We're plugging in 2 for n. Over 4 squared. So this becomes 3 cubed over 4 squared, which is 27/16. Okay, that is our initial value. That is our a sub 1. Okay. We already identified that r is 3/4, and so the absolute value of 3/4 equals 3/4, and that is less than 1, which means this entire series is going to converge. And in order to see what value it converges to, we follow the formula a times r to the k value divided by 1 minus r. We found that that top part is 27/16 divided by 1 minus 3/4, which gives us 27/16 divided by 1/4, which is 27/4. So that means this series is going to converge to 27/4. Okay, any questions on 1 or 2? Yes. However, a majority of this unit, you do have access to Desmos. Okay, you're just not guaranteed that every problem has Desmos. So let's hope we can do the math in our head. Okay. Okay, number 3 says, for what value of r does the infinite series for that summation of 17r to the n power equals 23? So in order to set this up, we have to set up our formula that a times k to the r power over 1 minus r. and see what it converges to. It already says what it's equal to, so we're taking that formula and setting equal to 23. Okay, in order to find the first part, I mixed them up, didn't I? Yes, it's RK. It's A times R to the K power. Okay, remember, in order to find K, we look at where the n value starts, and where does it start? 0. So I'm going to say that this function here, that 17r to the n, is now 17r to the 0 power, that's the AR to the K power, divided by 1 minus r. We don't know what r is equal to. That's why we are given what the summation is equal to. And then from here, it's just algebra. We have to solve for r. So the first thing I would identify is that r to the 0 power is 1. So really, I have 17 over 1 minus r is equal to 23. I can then multiply both sides by 1 minus r. So I get 17 is equal to 23 times 1 minus r. I can distribute the 23 and then subtract 23 over to the other side, which means I am left with negative 6 is equal to negative 23r. And then I divide both sides by negative 23, and I get r is equal to 6 over 23. That's my answer. Okay, so the only calculus part is this. The rest is we plug in everything and we get r by itself, and that's just using our algebra skills. Okay, and then the last thing, number 4, notice how it says calculator active, which means you have Desmos. It says if the function equal to the summation of n equals 3 to infinity of sine squared x over 3 to the power of n, then find f of 7. So this is what you're going to plug in on Desmos, and I'm going to write it on a different color just to show you that I'm not solving this by hand at all. So this is going to be the summation of n equals 3. And the only thing is on Desmos for this testing mode, you're not able to put infinity and use it to solve. So instead of putting infinity, what's another way that we can see the value as it approaches infinity? What could I put at the top of that summation? A very large number. So that's what we're going to put. Very large number. Okay, then you're going to do sine squared, and x is 7, so 7 over 3 to the power of n. And when you plug that into Desmos, it's going to give you your answer. So showing you this here. So I'm going to do sum for summation. I'm going to put 3 on the bottom, and I'm just going to put a big number up there. Okay, then I'm going to do sine. The only thing is you need to make sure that this is in radians, okay, because we're using a trig function. So sine squared, parentheses, 7 divided by 3. Close those parentheses, and then on the outside, the power of n. And of course, it's going to give me a problem here. For some reason, when on Desmos, and I don't know if it's just mine, because first period wasn't having any problems, but I have to erase that top summation and put it in again in order for it to give me my answer. And so here on my notes, I'm going to write that f of 7 is equal to 0.2996. Okay, I just rounded to 4 decimal places, and that's all I had to do to find that answer.